You ever just stop and think about it? That invisible network of tech just humming away silently right above our heads? Your phone's map, the weather report. So much of what we do every single day, it's all powered by space. And believe me, that's just scratching the surface. So today, we're going to dive into the absolutely incredible space tech that's not just running our world right now, but is literally building our future. So here's our game plan. First, we're going to pull back the curtain on that hidden infrastructure that's already up there. Then we'll blast off to the next industrial revolution. Yeah, it's happening hundreds of miles over our heads. We'll also talk about the kind of people, the pioneers and builders we need for this new age. And to wrap it all up, we'll see how this future in space is going to completely change our lives back here on Earth. Ready? Let's go. All right, let's kick things off with Section 1, our invisible infrastructure. This is that huge network of satellites that, honestly, most of us never even think about, but it's what makes our modern world tick. We're going to break down exactly how this whole thing works. Okay, so let's start with a simple question. How does your phone know exactly where you are? I mean, really think about that for a second. You pull up a map and boom, there you are. You're literally talking to satellites thousands of miles away. So how in the world do they just stay up there? Well, the answer is all about the beautiful, elegant physics of an orbit. And the European Space Agency has this fantastic way of explaining it. Picture this. You're on a super, super tall tower, and you throw a ball, right? It goes forward a bit, then curves down and hits the ground. But what if you could throw that ball so incredibly fast that as it falls, the Earth's surface curves away from it at the very same rate? Well, that ball would just keep falling around the Earth forever. And that, my friends, is an orbit. It's this perfect, delicate dance between forward speed and the constant pull of gravity. And what's really wild is that a satellite's entire job is basically decided by how high up it is. So let's look at this. Way down in low Earth orbit, or LEO, you've got satellites just whipping around the planet. We're talking 17,000 miles an hour, circling the globe every 90 minutes. That crazy speed and closeness makes them perfect for stuff like the high-speed internet you get from Starlink. Now you go a bit higher into medium Earth orbit, MEO, and that's the sweet spot for all our navigation systems like GPS. But then you go way, way up to geostationary orbit, or GEO. Up there, the satellites move at the exact same speed as the Earth's rotation. So it's like they're just hanging there, pinned to one spot in the sky. And that is perfect for things that need a constant view, like weather monitoring or beaming down your TV shows. Okay, so they're up there, but how do they actually talk to us? Well, the heart of any communication satellite is something called a transponder. Now, you can think of it in two main ways. The old school model is what we call a bent pipe. It's basically just a mirror in the sky. It catches a signal from Earth, mokes it louder, and just bounces it right back down, warts and all, including any noise or interference. But then you've got the much smarter, more advanced regenerative model. This thing is a game changer. It doesn't just bounce the signal, it actually grabs it, cleans it up, gets rid of all the noise, and then sends a brand new, super clean, high-quality signal back down to Earth. So that's the tech that's powering our world right now. But all of this incredible orbital infrastructure, it's also the launch pad for what's coming next, which brings us to our second section. Let's talk about the future. Let's talk about the next industrial revolution. And guess what? It's not happening down here on Earth. And this quote from Redwire Space just says it all perfectly. When gravity is removed, possibilities expand. Think about that. Down here on Earth, gravity is a factor in everything we make, every single process. But the moment you take it out of the equation, the rules of physics literally change. And that opens up a universe of possibilities that are, out of this world. So what does that actually look like? Well, for starters, it means we could grow perfectly pure crystals for revolutionary new medicines, things we just can't make here. Imagine you're on a mission to Mars and a critical part breaks. No problem. You just 3D print a new one on the spot. We could manufacture optical fibers so flawless, they would completely change communications back on Earth. And maybe the biggest one of all, we could start using materials we find on the moon or on asteroids to build the very habitats where future astronauts will live and work. We're talking about building in space with space. Of course, building stuff on Mars is a great idea, but it doesn't do us much good if we can't get there efficiently. And that's where these game-changing propulsion technologies come in, like nuclear thermal propulsion, or NTP. We're talking about cutting the travel time to Mars potentially in half. This tech turns a long, grueling 6 to 9 month journey into something much faster, making human missions not just a dream, but actually practical. But here's the thing. This amazing, revolutionary technology,
it doesn't just build itself. This future demands a whole new generation of pioneers, of builders, of thinkers, people with a really unique set of skills.
So, what's in the toolkit for building this future? Well, it all starts with the absolute bedrock, physics and math. You gotta know that stuff to figure out how to get from point A to point B. Then, on top of that foundation, you need the engineers, the people who design and build everything from the rockets to the robots. But all that hardware is just a fancy paperweight, without computer scientists to program the brains behind it all. And of course, none of this would even last 5 minutes without material scientists creating brand new stuff that can actually survive the brutal environment of space.
And these skills, they lead to some of the coolest jobs you can possibly imagine. You know, when we say space job, our minds usually jump straight to astronaut, but the reality is so much bigger than that. Yeah, we need aerospace engineers for the rockets and satellite systems engineers to manage the whole life cycle, but we also need space robotics engineers to build the bots that will do the construction and exploring. We need space debris removal specialists, and trust me, that's a huge job, cleaning up our cosmic backyard. We're talking about asteroid mining engineers and even, get this, space architects, people who will literally design the places we'll live on the moon and Mars.
And NASA puts it perfectly here. No one can build a rocket alone. This is not a journey for lone wolves. Tackling these massive, monumental challenges takes incredible teamwork. It takes people from all different backgrounds with all different skills and perspectives coming together and pushing the envelope of what we all thought was possible. Okay, so this brings us to our final and maybe most important section, our Earth space future. So, what does all this really mean for us back here on the ground? Because this isn't just about planting flags or exploring some final frontier. This is about building the next massive integrated platform for innovation and growth for the entire world. And just to give you an idea of the scale we're talking about, don't sleep on this. The space economy is projected to be worth $1.8 trillion by 2035. That is a staggering number. This isn't just another new market opening up. This is a fundamental, ground-shaking shift in our entire global economy. And the key idea to really wrap your head around is this concept of the Earth-space continuum. Basically, that line we used to draw between down here on Earth and up there in space, it's blurring, it's dissolving. I mean, think about it. A factory on the ground using real-time satellite data to make its assembly line more efficient, or a shipping company using its fleet of satellites to manage its trucks and ships all over the world. See? Space isn't some far-off place we visit anymore. It's becoming a totally integrated, strategic part of how we do business right here. And as we build this incredible future, we have to remember one crucial thing. It has to belong to everyone. Seriously. Building a sustainable, innovative future in space isn't just about solving engineering problems. It's a human challenge. And to solve it, we're going to need the best ideas, the brightest talents, and the unique perspectives from every single person, from every single community on this planet. And speaking of making sure we get talent from every corner of society, if you want to learn more about emerging tech and support this push for diversity, you should absolutely check out the A Black Girls Guide series on Amazon. It's a fantastic resource that's all about promoting diversity in these super important fields.